Right. So what you guys got? What you got? Ask me what you got. What you got? We got sleep deprivation, Mr. Watt. Okay, well, all right.
Section 322.
3-2?
202. Question 27.
27? Oh. All right.
You.
All right. Let's review. This is 27 and 3-2. This one here? Okay. Alright. So can somebody tell me what the slope of this is? Is it in the right form? What's the right form? What's the right form for, well, the only form we've talked about, but there's other ones, but the one we talked about, what's the right form for a line?
Y equals mx plus b.
Y equals mx plus b? Like it? And then whatever's here is going to be the what? Slope. And whatever's here is going to be the y-intercept. Kick ass. So is it in the right form? Yeah, because what does f of x take the place of? Y. So that really is just y. It's the outputs. So it is in the form mx plus b. So what's the slope? 2 over 3. What does that mean? That slope, what does it mean? I love it. Goes up 2 and over 3. Yes. And what's the y-intercept? So it's just...
I have a question. When I was doing the homework, sometimes the top would be negative and then the bottom would be positive. But then, like, when you're doing it, does it matter which one is negative or which one is positive?
Yeah, I'll show you a couple examples of that. Because you're supposed to be able to go either way. You should be able to go down, over and down, or back and up. It shouldn't matter. So the negative, and it's because math doesn't give a crap if I have negative 3 over 4. And you're all like, yeah, I know math. Negative 3 over 4 is the same thing as 3 over negative 4. But slope-wise, what does this one mean?
Down 3.
Down 3.
Positive 4.
So down 3 over 4. What does this one mean? Up 3. Hey, same line. I got to be able to go to my friend's house and then get back to my house. Please, dear God, let me get back to my house. All right? Can't get that from here. All right. So I like that question. What's the y-intercept here? Yeah, be more specific.
0.
0 negative 4.
0, negative 4. Remember, intercepts are points. So you got to answer me in the form of a point. Cool. And then I want to go graph this thing. What do I do first when I go to graph something from this kind of information? What do I have to do first? I got to get the y-intercept first, because the slope tells me if I start on the line, it tells me how to get back to the line. And the only thing I know about this line where it is that. So I have to plot that first, and then this will tell me how to get to another point on the line.
This
Scale is stupid important. Do not give me an answer like this and expect to be everything's great. That's crap. What's the scale? Is this 100? Is this a billion? Is this 0.2? Give me a scale. Give me some idea of what's going on. So the y-intercept is 0, negative 4, so that's going to be down 4. I like it. And then I'm going to go from there. What am I going to do from there? Up 2. Over 3. And then I can connect those to make a line. How can I make sure that that's looking good? How can I make sure that that point is right? What point is this? 3, yeah, up 2 over 3, so it's 3 negative 2. Up 2 over 3, so it's 3 negative 2. So if that is the correct point, if I did things correctly, what must be true about this point? What must this point do? Why is it special? Because it's on the line. Alright, it's on the line. What does that mean? Where did the line come from? Where did this line come from? I love you guys. You're like, I don't know, man. Somebody called it in. I don't know. It came from home. It's what it was. No, it came from there, right? It came from this. This is where that line came from. So what must be true about this point because it's on the line? What must be true about it? What must it do?
Plug it in.
Yeah, when you plug it in, it's got to work. That's all. And sure enough, if you plug a 3 in, because it's the point 3, negative 2, and 3 is the what piece? X piece. Negative 2 is the Y piece. When you plug a 3 in, what do you get? 3/3 times 3 minus 4. 3's cancel. What's 2 minus 4? Negative freaking 2. Alright. So you can always check to make sure that the point is the right point. Because what's supposed to happen when the point that's on the line is supposed to work in that equation? How many points did I just represent up here? No. How many points did it just represent up here?
4 minus 4, 2.
Infinite number. There's that point. There's that point. There's that point. I mean, the arrow says keep going. So I just picked up an infinite number of points, but what's true about every single one of those points? They work in this equation. Why is there an infinite number of points that work? Because there's an infinite number of numbers I can put here. And each one of them has an output all their own. So of course there's going to be an infinite number of possibilities. So again, I keep harping about this. That's the quickest way to answer. What are the answers to this? There they are. You'll find the one you want. Alright, maybe. That's all a graph is. On the most basic level, a graph is a visual representation of all the answers to this equation. That's what a graph is. Okay. Everything we do with them kind of stems from that fact. Alright. I like that question. It's a good question. You gotta be able to do that kind of thing. If I gave you a problem like this here, find slope and y-intercept and then graph. I think I gave you one like this on the practice test. What you got, Jeff? I don't know, man. 6y minus 3x equals, let's make it 4x, yeah, equals 12. I like it. Fine. What do I do? Can you see the slope and the y-intercept? Can you just see it? Why not? Why could I do this one so easily? We got the slope and the y-intercept. I didn't have to do anything. Why?
Because it's not in one.
Yes, this was in the right form. That one is not yet. So that's why we did. This is only one reason why. But this is one reason why we tried to figure out how to work when I have multiple variables. How do you solve for A when you got F times A over W and the old crap? Right? There's only two variables. I could have made this way. AY minus CX equals W and solve for, oh my god. So now you just got to solve for Y. So that idea is kind of freaky. That if I take any line equation and I solve for Y, everything just falls into place. But we didn't really prove it, but we sort of looked to see why it makes sense this is the slope. This is definitely the y-intercept. Because when you make x 0, you get b. There's just no denying that. So what do I have to do there? Add 4x. Start to get y by itself. So add 4x. I'm going to force that guy in front because that's going to be in the order mx plus b. And then divide by 6. So now you can do everything we just did here. The slope is 2/3 again, and the y-intercept this time is 2. So now I would start at 2 and go up 2 over 3. So tell me this, if I graph that, so here's 2, go up 2 over 3. So here's that line. What must be true about these two lines? What looks to be true? What kind of lines are they? Parallel. So why does that make sense? Because this slope is 2/3. This slope is 2/3. They're both going up at the same rate. So none of them's going to beat the other one. They're both going up at the same rate. They're going to be parallel. Oh, interesting. Parallel lines have the same slope. That makes sense.
Are we talking about 3, 2, then 9, 12, 13, 18?
So which one?
Oh, are we still on 3, 2, or?
Yeah, somebody asked me a question, number 27 in 3-2. And then I just kind of went off on that and said, what if I gave it to you like this? Solve for y, and then you can do everything we did over there. That one was nice because they already had it solved for y. But I'm not going to necessarily give you one that's solved for y already. Cool, I like it. But you know, this kind of thing happens. This kind of thing happens a lot in math. This is a circle. That's a circle with a radius of 4. See how everything's squared? The radius is 4. And the center would be at 1, -2. So that is like the form for a circle. And if I put any circle in that form, details about the circle's graph jump out at me. Do you have to know this for the test? No. I'm just trying to show you that this idea, solving, putting it in the right form, it happens with a lot of things. It happens with circles. It happens with freaky ellipses. It happens with weird-ass things called hyperbolas. All this kind of stuff is neat. The equation gives me an immediate idea of something that's true about what the graph would look like. All right, again, you're not responsible for this. That was just me showing you something a little bit further along. All right. What do you want to do? You want to do more of those, or how do you feel about those? Yes.
I have some questions about 2.6.
2.6?
Yeah.
Sure.
Let's see. We could. There's a y actually. It's like 55.
55. Oh, did we do that one?
55 or one of the word clouds.
So I think in this section there was that the average question, right? Let me see. Yeah, like number 98. I think I signed that one.
9.
So, so a problem like that one. If I had grades of 71, 87, and 79, and I have one more test to take, and I want my average to be at least an 80. I want to get at least a B minus. So I want to see, what does that last test have to be to make that true? So that's basically the same problem I assigned you. So what is that last grade? Beautiful. I love it. We're past the point where you're like, I don't know. Yeah, you do. It's X. Now, how do I find the average of 4 numbers? Yeah. Add them up. Divide by 4. I like it. So 71 plus 87 plus 79 plus X all over 4 has to be at least 80 though. So what's at least mean? Yeah, at least means it's got to be greater than or equal to. Right? If you have to be at least this tall to ride the ride, you have to be that or more. Not that or less. That would be freaky. All right, and then you just work this bad boy out. What's a good first step here? What's the ugliest part about this? If it wasn't there, it'd be easier. That's stupid what? Stupid what? The stupid 4, right? And it making the whole thing worse? No. Do you see what I mean? Anytime you have a fraction inside of an equation or an inequality, you're allowed to kill it. Because there are two sides that will balance out what you want to do. What do you want to do? I want to multiply by 4. Oh, thank God there's another side that I can do to both sides then. So I'm going to multiply by 4.
Because there's 4 integers.
Well, why did I put a 4 here in the first place?
Forget.
How many numbers do I have total at the end? 4. How do I find the average of any 4 numbers? I add them up and divide by 4. How do I find the average of any set of numbers? Add them up, divide by how many there are. So now why am I multiplying by 4? Just to get rid of the damn 4. Right? It's making a bunch of fractions. I don't want that. And then if I add these together, that's 150, 237 plus x greater than or equal to 320. Now when I subtract, I'm going to figure out what that grade has to be, at least, to make that happen. So when you get x, it's got to be at least. Oh, this is a different problem, right? Yeah, so 83. 83. What's up?
Sorry, forgot my water bottle.
All right. Real quick, I want to show you something kind of neat. Oh, yes.
The word C are supposed to multiply that whole equation by 4, but then, again, I felt like the 4 disappeared.
Of course it does. Because what is 4 divided by 4?
It's 1.
Yes, they cancel.
But what about the top part of the equation?
What about it?
You're not.
You don't multiply.
How do you do this? 8 times 3 over 8. How do you do that? So the 8s cancel?
Yes, okay.
Is there an 8 left for the 3?
No.
No. Don't the 4s cancel?
Yes.
Is there a 4 left to go through the top?
No.
All right. I like it. I like it. Real quick, I'm going to show you something real kind of fast. If you don't get what I'm saying, it's okay. I just want to show you. What did I want I wanted to be around, I wanted to be like an 80 or more, right? How do I make this average become 80? Well, how far from 80 is this? 9. It's down 9 from 80, right? This is, how far from 80? It's up 7. And how far from 80 is this? I'm down 1. So overall, I'm down 3. So this has got to be up 3 from 80. Holy shit. That's kind of neat. All right. If not, it's okay. Kind of a nifty thing about averages. If I tell you 4 numbers average to be 80, I don't know anything about the numbers except that they have to add to be 320. And I can move that around. I can move how far over it is. Now for under it, I can move it to a different number. So that's why that kind of works. That sum comes out to be 320. Okay, enough of that. All right. Where else do you want to go? Yes.
For number 6 on the breakfast test.
Yeah.
For the fine slope of the line.
All right, so there's 2 ways. I think on the answer key I showed you using the y2 minus y1, but since I have you graph them, you can just count up and over, or down and back, whatever it is. So if I give you 2 points, 2, -3, and -1, 2. There's 2, -3, and -1, 2. And I want to know the slope between those points. I could just count how far up do I go from that point to that point. 1, 2, 3, 4, 5. So I go up 5. And how far back do I go? 1, 2, 3, 4. So how do I put together the slope from that? What's the slope it's going to be? What's the slope in words? Rise over run. How much did I rise? I'm trying. Poor little 5 got really tired. Up 5, right? So I rose 5, and how much did I run? Back 4, so -4. So -5 fourths. So if I give you the graph, or if I ask you to graph points, you can just count between them to see what the slope is. How do I do it algebraically? What's the formula for the slope? Something I wish more people would realize is these stupid little subscripts, they don't matter. All they want you to do is if I do -3 minus 2, I have to do 2 minus -1. I have to go in the same direction. That's the only reason those stupid subscripts exist. But some people look at them and think it's a square, or some people get confused. What the hell? Which one's got to be the first one? Who cares? Just go the same direction. That's the only reason those subscripts exist. So if I go -3 minus 2, where's that going to go, on the top or the bottom? Top, because that's where the y's are. Y's, rise. Gotta love that. So -3 minus 2 on the top. And then I can't do -1 minus 2, because I already said I want to go this way, so I got to do 2 minus -1, 2 minus -1. And that's where people are going to make another mistake with the negative, right? So then you get... Did I just count wrong? Is that what I did? Oh, I see. I started here. That's a good job, Jeff. 1, 2, 3, 4. What did I do? 1, -1, 2, and 2, -3. So you go up 1, 2, 3, 4, 5, and you go back 1, 2, 3. What did I say? Back 4. That's good, Jeff. Because what do you get over here? -5 over minus the negative is plus -5 over 3. Cool. So you should get the same answer either way. Just make sure you count right. So if I give you the graph, dear God, just count. Just count between the points. If I give you points, no need to graph them. Just throw it into this equation. Do you have to know this equation? Yeah, you probably should. I'm not going to give it to you. I'm not going to give you mx plus b either. Right. Yeah, that's because you're mean, Jeff. Yes. Exactly. Special class. And how to be extra mean. Got A++. All right.
On the test, do we have to scale the graphs yourself? Or
Yes. I like it. And do better than I just did. I want you to show me scale. Because you could make the scale go by 2's. If I gave you, so if I gave you this, and you have to plot the point 8, 12, then you can go 4, 8, 12, 4, 8, 12. You could choose your scale, you just got to show it to me. I'm not going to do that to you a lot, if at all. Give you some freaky ass point that you have to figure out the scale for, but the scale can be, as long as it's consistent, this scale could be 2, 4, 6, and this scale could be 10, 20, 30. As long as it's consistent on its own axis. I like it. The scale has got to be consistent. If it's not, then you can make anything look like a straight line. And that's no good. All right. Yeah. So I gave you several word problems on the practice test. I think some of them might have been a repeat from something else I gave you early in the semester, but oh well. So I'm not going to give you necessarily 4 word problems on the actual test. We'll see. That would be the upper bound of the number of word problems I give you. Let's try something out of the book though, just to get something different. Yeah, there's a lot in the homework related to stuff like this here. Let's say there are 10,000 people in a certain city. Each year, the population grows by 750 people. How long until they have? Oh, what you got, Jeff? Oh, let's make it 16,050 people. All right, so they like this kind of problem in this book. Which makes sense. It's a problem that happens all the time. Population growth, stuff like that. Or even just losing people if you're losing too many people. So what's my unknown? Yeah, how long? And that's measured in what? In this problem? Years. So X is going to represent number of years. And then how do you set this problem? You start with 10,000 people. And then every year you add 750 people. So if I waited 3 years, how would I figure out how many people I'm going to add on top of 10,000? If I waited 3 years, 750 times 3. So if I wait X years, I'll have 10,000 people plus 750 times X. Once you do enough of these kind of problems, you start to realize, and this would be like a plumber problem. The plumber charges you $40 just to show up at your house, and then $30 an hour. So it'll be 40 plus 30X. You got this much money, how long can you stay out there, blah, 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 whatever. Right? So what do I want this to equal?
16,850.
16,850. I like it. And then you just solve like always, right? It's setting up the equation that should be the problem. And you guys are like, yes. But please, I always hate when somebody gets the right equation set up, but then you make a mistake solving the equation. That should be the easy part, solving the equation. So did I make a nice I don't know. Hopefully I did. I tried to do it real quick in my head to make something interesting. That works. 6,850 divided by 750. Doesn't look like it's going to go in evenly. Too bad for me. Too bad, Jeff. But it comes out to some number of years, right? Hopefully. If you want to know the answer, you can plug it in your own calculator, I guess. But see, the important thing here is how to set that up. Solving the equation should be not a big deal, especially with this kind of equation. Not a big deal. I mean, they do have a couple of regular word problems. These are less interesting. That's fine, Jeff. We don't care about interesting. All right. You know, something like the one about the average yearly salary for a master's versus a bachelor's. That one I almost call just one step away from an equation, really. So if I said the number of students passing stats is what you got? 40 less than 3 times the number failing. If I have a total of, oh, I guess I should make it work. That would be good, Jeff. Total of 760 students in stats. How many pass, how many fail? So this is what I call a classic word problem. There's players in this thing. You got to give them math names, and you got to set up the equations for it. So what are the players in this problem?
3x minus
No,
40.
no math. I don't want to hear math right now. I don't hear math, but I don't care. What kind of students? There's how many players are in this? How many groups of people are involved in this problem? 2. Who are they? Passing students and